Hello, today we're going to learn how to use the Peak Location Classifier tool. Peak Location Classifier allows you to find a spectrum with a certain peak, a peak that you tell it to, you input the peak with a certain tolerance, so many nanometers to the left or right of this peak, and it will produce a classification file similar to Spectral Angle Mapper, in which the pixels are identified as having the peaks that Peak Location Classifier finds, the peaks that you specify. Whereas Spectral Angle Mapper, however, identifies spectrum and colors them as matches. It does so by matching the certain shape. So the spectral shape is what's identified in Spectral Angle Mapper, whereas Peak Location Classifier, it doesn't matter what the shape of the spectrum is, just where the peak of the spectrum is. So to use this tool, it is in the Cytoviva Analysis tab, and down at the bottom here, the second to last feature here is Peak Location Classifier. So you have to, just like Spectral Angle Mapper, you have to input what image you are searching for these spectral peaks on. In this case, we have our cell with particles again, example. The dialog box shows up, and in this dialog box we have peak location, which you identify as, tolerance in nanometers. So 10 nanometers would be 5 nanometers to the left and the right of this peak. So anything from 645 up to 655 would be identified. And then this is important parameter here, noise floor. This indicates for it to be counted as a peak, it has to be above a certain threshold, noise floor. So I always recommend that this is higher than 1000, assuming you have good signal to noise ratio in your data cube. And then smoothing level, this is when it gets to the top of the peak, there can be these little bits of noise. It's not exactly a perfect peak, a perfect spike. It can kind of have these little edges. This will smooth it off like a clipping feature. And you have the option to have it be the largest peak in the spectrum, which most people choose this feature. However, you can have it be a secondary peak in the spectrum. By clicking this box, it'll identify a peak that's not the largest peak. Maybe it's a secondary peak. And then just like Spectral Angle Mapper here, you have these feature for saving the classification file and then the rule image. And just like SAM, Spectral Angle Mapper, we do not want to use the rule image. So we'll uncheck this box. And usually what I do is I usually will run this first. So I'll usually commit this to memory, and then you can go and save the classification file that it produces afterwards if it works out or you agree with the results, although the results are what the results are, right? So first thing I like to do though is find what the noise floor is, and maybe let's search for where these peaks are. So in order to do that, in order to get back to this image and see where these peaks are, these particles, or what the noise looks like, what the peak intensity is, we have to close this. So it's kind of something you have to know before you launch the program or launch the tool. But you can close out of it. And I'm just going to use the live spectra window here to go to a particle and kind of see most of these peaks here are right around the same area. I think, there's some that are further out into the red, but let's just go ahead and take this one for example. We're going to zoom in on this. And we know here from our previous ENVI tutorials, you can zoom in on this part of the spectrum here, which I'll do by holding the middle mouse button and drawing a box around it. And we see the peak is right here. And down at the bottom left of this spectral profile box, you see, of course, the first number is the band number, the second number is the wavelength number exactly, that's 650. And then 9080, the next number is the intensity. So this has a peak of about 650 and a strength of about 9000. Click the middle mouse button again to zoom back out. And I'm pretty certain that most of these particles have peaks that are over 6,000 or 7,000 here. Let's just take a look here. Looks like 8,000, 10,000. So We could set a threshold of about 8,000, and I think would be good. 7,000 maybe, just to be safe. So I can close this, and we go to Peak Location Classifier. I'm going to run it on this sample here, and it's already defaulted to 650, so that's kind of convenient. And let's make this a little tighter. Let's say 4. So it's going to be a couple nanometers to the left or right. The noise floor, we can say, let's say 7,000. Must be the largest peak in the spectrum. Sure, these don't have any secondary peaks. Don't want the rule image, and we'll just do this to memory. So this runs just like SAM does. It's looking at every pixel, seeing where those peaks are. And then when we're done, just like SAM, just like Spectral Angle Mapper, it makes this classification file, and if we remember, it's this colored checkerboard icon here, and we can load it into a new display by right-clicking it. And we see here all the places that these peaks show up as a separate file. Remember, a class file is just a black image with colored pixels over it that identify matches. And with Peak Location Classifier, since you're just looking for one peak, it's always going to be just one color, and this color just happens to be green, and you can change it when we do this overlay here, just like with Spectral Angle Mapper. But this is just showing what a classification file again looks like. It's the same dimension as the file in which you are classifying on. So I'm going to close it. We can actually, just like Spectral Angle Mapper, we're going to overlay classification. It's this memory file here. And here it says peak at 650. So again, we can look at it like this, where the unclassified pixels are turned on as well as the classified pixels. You can uncheck this box though, and now we should see some areas where these classified pixels are. Let me go over here, uncheck the classified. And if we go to See Profile Spectrum and we go on this pixel here, we see this has a peak at 648, so that fell within the 2 nanometer tolerance. So we can obviously make a wider tolerance here, maybe a 10 nanometer tolerance will classify more pixels. But if you wanted to know every pixel in the image that had a peak at exactly 650 with a little bit of wiggle room on either side, this would give it to you. And again, just like Spectral Angle Mapper, we can edit the colors. So we can make this red. So now these are all red pixels that show up. And we can also get the distribution. 95 pixels in this image have this peak. And when you're done, if you want to save this file, we can save these changes. So it's always red. If you ever want to save a file that's in memory, just right-click it, Save Selected File to Disk. So we could just save this and just say, AUNP cell. .650 nanometer peak. Okay. And so now if we close this file, we want to reload these classification files. It's simple. We just go to overlay class classification, and we're going to do it onto this. Oops. So I have to open this classification file. So I go to New File. And I just saved it on the desktop, AUNP cell peak. And here it is. So you can always get back to it. And that's how to use the peak location classifying tool. Thank you.